That looks fine. Why is my iPad not connected? Let's see. There we go. Yep, that works now. I think. Just give it a second. Yeah, there we go. Okay, I can see the screen on the YouTube thing now. So, well, sorry for the delay, but this is my first time streaming live, so I'm just trying to get used to all the things. Yeah, so welcome back to Daily LeetCode Live, and we are going to do today's LeetCode question, uncut. So let's do this. Let's refresh the page. Okay, there we go. Okay, so our problem today is design a number container system. So what does the question want? So design a number container system that can do the following. So we are making some class today, I guess. Insert or replace a number at the given index in the system. Right. The second thing we have to do is we have to return the smallest index for the given number in the system. So I think we should just look at the example. This is a bit vague, I guess. So let's look at the example and we'll know exactly what we need to do. So first of all, we are creating it here, and then find so there is no index that is filled with the number 10, so therefore we just return -1. Okay, so yeah, that's what it says here. So if the number does not exist, we just return -1. So what else do we have? We have change. So change would be, let's see. Change. Right. So when someone runs change, it means that we want to fill index 2 with the number 10 there. Right. And after a bunch of changes, it runs find again. So we want to find the smallest index for the number 10. Well, since it has been allocated to 1, 2, 3, 5 index, the smallest is 1, so we have to return 1. So just by reading this makes me think that we need some ways to store for each number the list of indices that has to be sorted, or at least use a heap or something, so we always get the minimum. Yeah, actually I think a heap will work perfectly here. A min heap, which is implemented in Python already, which is great, I think. Yeah, so yeah, and then when we change 20 with 1, your container at index 1 will be filled with number 20. So this is like an edge case, I guess. So the 10 at index 1 got replaced. So if I have to draw this out, it will look something like this, right? So you have some imaginary container that, if we look at the bounds, it has 10 to the power of 9. Like the index could go up to 10 to the power of 9. Of course, we can't make an array that big, so we have to use some map to instead of making an array. and well, we only have 10 to the power of 5 cores. That's 100,000 cores. So a map will work just fine here. Yep. And so what do we have to consider? The first thing, if we ignore the replacement and stuff, well, if we look at the example, if we look at example one, if we have a map and then we store the indices, so something like this. So this is up to this step here. When we do a find, well, we can just get the first element, right? So if we have a heap, it doesn't really matter like what the number, like how the numbers are ordered at the back. So like the idea of a heap is you can get the smallest number really quickly. Yes, but then actually now that I think about it, like when we are thinking about the replacement part, what happens when we want to replace like 2 or something? Well, actually, in that case, it wouldn't work for the heap anymore, right? Well, that's because, for heap, we can only have access to the first element. Well, like we can only have access to the smallest element. So we don't actually know like how these numbers are stored. Like they could be like all jumbled up. So I don't know, 325, something like that. So well, if we replace 20, like if we replace index 1 with 20, well, sure, then we can just remove this, right? But then what if we want to change the second index? Well, in that case, I think one way to do this is we have another separate map that stores the current index, like for each number. So like we store, like we have a map that basically like has key, like the key will be the index, and then the value is going to be like the number, right? So in this case, like for example 1, we will have a map that basically stores like 2. So these are the index, this is the number. So it will store 2 to be 10, 1 to be 10, 3 to be 10, and then 5 to be 10. But then when we do 20, we want to replace this as 20. So the trick is, when we are finding 10 now, every time we find, we want to actually check back to the map whether at that index it is still that number. If it is not, we want to remove that, and then we check the next one. So we check 2, and then and so on. And like now when we check 2, well, yes, it is still 10. So we can guarantee that that's the smallest. So another property of heap is that when you remove an element, when you remove the smallest element, it automatically adjusts so that the next smallest element is at the front, so we can have access to that. And well, let's say, like all the numbers are changed, like something like this. Well, we will have nothing left in the heap, so all of these numbers will be crossed out. And when it is empty, well, we can just return -1 at that case, because there are no index that still has that number. And you might ask, like, don't we have to like technically do like don't we have end heap operations here? Well, but then it is kind of amortized. So because we can only add, we can only change 10 to the power of 5 times at most, right? So like the number of times we have to actually remove the front element is at max 10 to the power of 5 times. So since heap operations are log n, uh, our solution would be n log n. And yeah, let's get coding. I'm pretty sure my algorithm is correct. Yeah, so let's just get coding now. So initially, we want to have a index to number map. So so we'll call this the index map. And we also need a heap map. So in Python, to use heap, we can just do import heap cube. Yeah. And now we want to actually do stuff here, right? So when we change an index, well, the first thing we have to do, we have to we have to update the index map first, obviously. So we have so at index, we will have number right now. So that's the first thing we have to change. The other thing we have to change is we actually have to add we have to add the index to the heap. So but then like we could have empty heaps. So I'm just thinking whether we can use default date for heap. I don't think so. Wait, but we can initialize it with a list. So basically in Python, like when we want to use heap, we are basically just wrapping a Python list into it. So if we just do from collections, import default date, and then we can do default date here, use list. So basically what this like when we normally initialize a heap, we initialize like with the listing anyways. So we can just do that. And then well, obviously we want the heap map of the current number. We want to push the current index in. So heap push. If I'm not wrong, the first parameter is the heap. The second would be the thing we want to push in. So for heap map, like we are basically storing for each number what index, what indices, what indices are there for that number. So we just do that. And then when we do find, well, this is like we have to be mindful of all the edge cases. So the first case, we don't actually have that number in the heap map, so it's just empty, right? Like we have never seen that number before, so we just want to return -1 there. Well, we can also actually make a constant up here to just make things a bit more clearer. So if so if number is not in the heap map, like we've never seen that number before, well, we just want to return not found. So otherwise, that number is in there. So what we want to do now, so while number, actually while self heap map number, so that's the heap map associated with that number, while it is not empty, so we can just do that. We can think of a heap just like a normal list with the heap operations, like where you are doing the heap operations on it. So like if a list is not empty, basically this is what it is saying. Well, we want to get the front, so so the current index would be equal to heap map self.heapmap.number I only remember like to pop it, but what is I'm gonna search up the method for getting the first element in a heap. So Python heap get first element method. Right. So because of how the heap is sorted, we can just do heap map 0. So like the 0th element is guaranteed to be the smallest. So yeah, I totally forgot about the whole list thing. So yeah, that's how you get it. So after we have the current index, what do we want to do? Well, we want to check whether, like for the index map, it is still like whether that number, like whether that index still store the current number we want, right? So how do we check that? Well, we can check so this is the smallest, like this is the index that we want, right? And then when we look at the map, if it is equal to number, well, then we know that we have found like the correct solution, right? So we can just return well, this is current index. Well, actually, I'm gonna separate it out because this looks a bit massive. So we can just do that, and then we can just do return current index. So otherwise, that means for that index, like think about the, like this case here, like index 1 was originally initialized with 10, but now it is being changed to 20. So what do we want to do? We want to update this heap, right? So we want to basically just remove the first element, and then we'll get the next element. So we want to do heap pop, and then, well, this is the map for the number, and we just keep popping until we have access to the smallest index where like the corresponding number is still the same. So if we do that, we can like eventually find the index, or we could have popped all the index out and we just return not found here. Like the heap map is now empty now when it reaches that line. So I think that should work. Let's see if I make any bugs. Oh, what did I do here? Should do self.heapmap. Yeah, that looks fine. Let's see if we ran into any edge cases that I missed. No, that works. Well, thank you for watching the stream. I'll see you next time. Bye.